In the last video, I showed you how we can take a point and a slope and use them to draw a line. Now, how could we come up with an equation for that line if we know a point and the slope? Well, to start with, remember our formula for calculating the slope based on two different points. If we can take this equation, m stands for the slope and it's equal to y2 minus y1 over x2 minus x1, and multiply both sides of this equation by what we have in the denominator, x2 minus x1, that will allow us to cancel the denominator over here on the right. So now we just have m times x2 minus x1 equals y2 minus y1. Now suppose instead of two particular points, we're working with one particular point, and then the second point can just be any generic point anywhere on the line. So I replace the x2 and y2 standing for the coordinates of a specific point with just plain old x and y that can stand for any arbitrary point on the line. So now we have an equation where any point on this line has to satisfy this equation. It's usually written with the y part on the left and the m and x part on the right, so it looks like this. And it's called point-slope form because it involves a point and the slope. So you can use this equation, this form of a linear equation, to write an equation for a line when you know the slope and at least one point on the line. So the m in this equation stands for the slope. If you have a specific number for the slope, you put it in place of m. And the x sub 1 and the y sub 1 are the coordinates of any particular point on the line. So the things that are in red here get replaced by specific numbers, and the things that are in blue, you just copy those over. Those are part of the equation. So let's see how this works. Suppose we want to write an equation for the line with slope 5 through the point 4, 3. That would look like this. And since the slope, we want it to be 5, we put 5 in place of m. The x-coordinate of this point is 4, so we put that in place of x1. And the y-coordinate that we want is 3, so we put that in place of y1. And we have the equation y minus 3 equals 5 times x minus 4. So every point on this line is going to have coordinates that make this equation true when you stick in the x-coordinate here for x and the y-coordinate here for y. Now we can either leave the equation like this. If we don't care what form the equation is in, this is as good as any. But we can also do some things to rearrange or simplify this equation. We could distribute to remove the parentheses over here, and then it would be y minus 3 equals 5x minus 20. If we want it solved for y, we can get rid of the minus 3 by adding plus 3 to both sides, and then it's y equals 5x minus 17. Notice the 5 is still part of this equation. We can still see that we're dealing with a line whose slope is 5, but the minus 17 here doesn't really have any direct relationship with these that you can really obviously see. So neither one of these numbers shows up here. Instead, we have a minus 17 that came from multiplying and rearranging. Let's try another one. Write an equation for the line with slope negative 1/2 through the point negative 7, 2. So just rewrite this point slope form, but with those three numbers in the appropriate places. Y minus 2 equals negative 1/2 times, in parentheses, x minus negative 7. And of course, instead of writing minus negative 7, we could just write plus 7. So y minus 2 equals negative 1/2 times x plus 7. And if we want to get the parentheses out of the way, we can multiply that out. Y minus 2 equals negative 1/2, and then the negative 1/2 x, and the negative 1/2 times 7 is minus 7/2. And then we can add 2 to both sides. Over here I'm adding it as 4/2, so that we have a common denominator, and we can combine the negative 7/2 plus 4/2 into minus 3/2. So we can say y equals negative 1/2 x minus 3/2. If you check that by plugging negative 7 in for x and doing the calculations, y does come out to be 2. What about an equation for the line through the points 1, 7 and 5, 9? So here we just have 2 points, and we want to go from 2 points to an equation. So this is a 2-step process. Step 1, find the slope. And then step 2, use the slope and one of those points to write the equation, just like we did in the last couple of examples. So we've already seen how to calculate the slope here. 9 minus 7 over 5 minus 1 is 1/2. So that's the slope, and we can take that and either one of these points, I'll just pick the first one, and stick them into this point slope form. Y minus 7 equals 1/2 times x minus 1. Without the parentheses, that's y minus 7 equals 1/2 x minus 1/2. And I could add 7 to both sides and get y equals, notice 14 over 2 is just another way of writing 7, so that I can combine the fractions and get y equals 1/2 x plus 13/2. If we had used 5, 9 instead of 1, 7, right here, when we put things into point slope form, it would have simplified down to this same equation. And with this equation, you can test it. If you plug 1 in for x, y comes out to be 7. And if you plug 5 in for x, y does come out to be 9. Now, when we have an equation in that form, y by itself on one side equal to an x term plus a constant term on the other side. Y equals something times x plus some number. That's called slope-intercept form. Because when an equation is in that form, the m, the number in front of the x, is the slope of that line, and the b, the constant term that's added on, gives you the y-intercept. The place where the line crosses the y-axis is the point where y is b and x is 0. So what are the slope and y-intercept of y equals 2x plus 5? That is in that slope-intercept form. It's y equals mx plus b, where the part of m is being played by 2, so that's the slope, and the part of b is being played by 5, so that's the y-intercept. And I would accept either just the number 5 or the coordinates of the point 0, 5. So here we have a line that crosses the y-axis at the point 0, 5, the point on the y-axis where y is 5, and the slope is 2. So that's the direction it's going. It's going up 2 and over 1 from that point. What about the line y equals x minus 8? What's the slope? Well, that would be the coefficient on x, and here that would just be 1. And what's the y-intercept? Well, here, if we think of this as 1x plus b, the b would be the number negative 8. So that's the y-intercept. What about y equals 1/3 x plus 2? The slope would be 1/3, and the y-intercept would be 2. What about if y equals negative 5/4 x? For this line, the slope would be negative 5/4. What about the y-intercept? It looks like there isn't a b, but if we want, we can think of this as negative 5/4 x plus 0. So the y-intercept is 0. or 0, 0. So here's a line that crosses the y-axis at the origin. What about y equals 11? Doesn't look like there's an x here at all, does it? But we could think of this as 0 times x plus 11. So the slope would be 0, and the y-intercept would be 11. Okay, what about 2x plus 3y minus 6 equals 0? The slope would be... The problem here is that this equation is not in slope-intercept form. It's not arranged as y equals mx plus b, with the y by itself on one side equal to an x... with the y by itself on one side equal to an x term plus a constant term on the other side. So, if we're going to be able to look at this equation and see what the slope and the y-intercept are, just from looking at the numbers that make up the equation, we first have to wrestle it into that slope-intercept form. We have to get it solved for y. So let's do that. We can leave the y term where it is, but get rid of the x term and the constant term, subtract 2x and add 6 on both sides, and then it's 3y equals negative 2x plus 6. Now we need to go from 3y to just y. So we do that by dividing by 3. And notice both terms have to get divided by 3 on the other side. So when you take the negative 2x and divide by 3, you've got negative 2/3 as the coefficient on x. Plus, when you take the 6 and divide by 3, you get 2. So now this is in slope-intercept form, and we can look at this and see, aha, there's the slope, it's negative 2/3. And there's the y-intercept, 2. Or you could say it's the point 0, 2. A couple of special cases to be aware of. If you have a vertical line, one that just goes straight up and down, you're not going to be able to put it in slope-intercept form because the slope is undefined. But you can write an equation for a line like that, and the equation would just be x equals some particular number. So if you have an equation x equals just a constant, and you're interpreting that in terms of both x and y, that would be a vertical line. For example, the line shown here has an equation x equals 5. So what all of the points on this line have in common is that their x coordinates are all equal to 5. X could be 5 and y could be 2. X could be 5 and y could be 6. X could be 5 and y could be negative 6. But everywhere on this line, x has to equal 5. And then if you have an equation that just says y equals some particular number, then you've got a horizontal line. This particular horizontal line, the equation is y equals 4. So all along this line, all the points have y coordinates equal to 4. And then x can be anything at once. X can be negative 1 and y is 4. X can be 3 and y is 4. X can be anything and y is 4 all along this line. So y equals just a number. The graph is a horizontal line.